Okay, so we have our game set up here to now we need to put a worm at the end of the tunnel and maybe make the worm fly back and forth. So, and then the bird would have to pick up the worm and then we would display some kind of message. So, let's go. We could get a worm image. I can see if we have worm animals. Oh, there we go. It's a snake. That'll do for right now. So we have, let's see what this looks like. About the right size that I want. Okay. So what I want to do is start a worm right here, and then get it to bounce back and forth like boom, boom, just kind of oscillate like that. Okay. So let me first put the worm in the world. So in the world, I will put private worm W, worm, or W equals new worm. And let me add object W to like 550, 200. So 550, 600 is the highest pixel, so I'm getting pretty close to the right edge. 200 is right in the middle vertically, so he's going to be right in the middle. Basically right where I wanted him. Okay, so he starts there, and I'm going to go to the worm class. So you could do this a couple of different ways to get it to bounce back and forth. So one way to do it is to continually set the location to be one bigger than the current y coordinate is. And then so like if you had one, let's try it. Let's create a boolean up and let that be false. We did something very similar to this to get the bird to animate, to flap. So essentially what we're going to do is every time act is called, we're going to set the location. So let me just do it like this first. So set location, get X, leave it the same, get Y, -1. So what this is going to do now is it's just going to move it up one pixel at a time. But then when it gets to the top of the screen, it's just gonna keep going or stay right there. Okay, it's not gonna keep bouncing back. So what I want to do is, that's what that boolean up is for. So I guess I would set that to true, really. So started out to be true, and here I can say if up is true, okay, then I will do that. Alright, and the else to that, which means if up is not true, up is false. So one needs to make sure that's clear. This is checking it to be true. Okay. If it's not, then I'm going to go the other way. Set location, get X, get Y +1. So now, if up is true, it'll go up one pixel at a time. If up is false, then it'll go down, which is adding 1 to the y coordinate every time act is called. So you're probably thinking, well, up's just going to be true. What's going to make up become false? So up will become false if we ever get to the edge. So there is a built-in method. You could check the y coordinate equal to 0, or check the y coordinate equal to 400. But I will say if is at edge, that's the name of the method. Let's take up equals not up. So what this does, it seems kind of confusing at first, but when this variable, the way that assignment works, as is mentioned, is the right side gets assigned to the left side. So when up is true, that negates it to be false, and we assign up to be false. When up is false, we negate it to be true, and we assign up to be true. So essentially this statement just changes it to the other. Okay, so let's try that. And we'll just see the worm to see if it basically does what we think it's going to do. Yep. Okay, so it's going to oscillate back and forth. Probably need to speed him up, but that's how that happens. Another way you could have done it is to use the move method, which moves you in the direction that you are facing. So then what you would have had to do is change the direction. If you wanted the snake to actually like point going that way and go up, you'd have to set the rotation first. Then you could just move, which would move you in the direction that you're facing. So let's speed it up a little. Alright. Let me try 3. That'll be 3 times as fast. I don't know how fast it'll be. That's pretty much what I think. Well, it's good. Okay. So right now we have a bird that flaps, animates, and we have tubes that hinder us from going through it. We could only go between them. And right now there's still no interaction between between the bird and the worm. So that's the last thing we're going to do. Get the bird and the worm to interact. So you could do this in bird or worm, really. I'll do it in bird. Actually, I'll do it in worm, just because worm. And the only reason this is there's just less code in worm, so it'll be the only thing. It'll be easier to troubleshoot if something went wrong. I could just go right to the worm class. So let me pause this. Go back to worm. Okay, so I'm back in worm, and what I'm going to do in the ACT method, all these things can be true. So this else just is tied to this if. This is a separate if, and I'm also going to do an if. Well, let's do the same thing we did before. The actor A equals get one intersecting object. And it would be, I'm in worm, so it would be bird. Bird class. Okay. So here's where one thing we'll talk about is if A is not null again, because ACT's going to get continuously called. So if it's not touching a bird, it's going to be null. And we don't want to call a method from a null object. You'll get something called a null pointer. So what I want to do, if A is not null, is first I'm going to display a message. Let's say get world. So the message that I'm trying to call is called show text. Well, show text is a method of world or my world. Okay, so you can call the show text method straight from my world. You don't have to get the world first. But if you're calling it from worm, you have to get the worm's current world, which will be my world, and then show text, and let's say you win, and I'll put it right in the middle of the screen. So get world, show text, you win 300, 200. So let's see that works first. So this is okay. Since all that new, you saw it kind of like stall for just a second, and it says you win. I guess we could also remove the worm. That would make sense. And so you have to be careful. There's a method called remove object, just like there is add object, but those methods are in world, so or my world. So you have to remove an object, you first have to get the world to be able, because it's a world method. So you have to get the world, just like show text. You have to do remove object, and then if you think about how are we going to talk about what we want to remove, it's not A, right? A is the bird. What we want to remove is worm, but we don't have a worm object in this code. It is the class of worm. So what you're actually going to do is use a keyword called this. Notice that it comes up as a color. And it is whenever you're talking about an object of this type. So if we put a lot of worms in the world, they would all use this method as their code. And if one was touching a bird, it would be that object called this. It's just whatever worm is calling the method. So now we should have, and I think the difficulty is just about right. Okay, so it goes away, and we get the "you win" message, and we have our basic Flappy Bird game created, basically from scratch. So one thing I'm sure you're probably thinking, there's several ways you can improve the game. Number one, I think you could get the worm to move a little differently than just going up and down. Because right now the only hard part of the game is getting through the tubes. Once you get through the tubes, the worm's going to run into you. So, but you could get the worm to move at a random location, as long as it's somewhere in between here, and then that way it's kind of like teleporting or something like that. So there's a lot of different things you could do. You could also get the worm to interact in this part of the world, but then the bird wouldn't have to go through the tube, so that's kind of defeats the purpose. I'll try one here for a worm instead of, well, let me comment this out because it actually works pretty good. But the last thing I'll do is I'm just going to get a random y coordinate. I'll call it R, and the y coordinates go anywhere from 0 to 400, and I'm going to say set the location get x R. So this is going to happen every time act is called, so I'll show you what it does first. He's just going to be like really fast to where you would never be able to catch him. Okay, so those are just random y coordinates. But what you can do is, similar to what we've done before, create a timer and only do that teleporting thing every now and then. So if I had a private int count, I'll set it to 0. In my at method, I will increment count. And then I can say if count is greater than or equal to, let's say, 40. Remember that I'm doing 2 lines of code here. So then this if statement needs to be inside braces. I want to get it first, set the location, and I also want to set count back to 0, because what would happen if I didn't set count to 0 is once count reaches 40, this would always be true, and it would do the same thing that it just did, continually set the location to a random y coordinate. Now I will set it back to 0, so it will have to wait another 40 counts before this is called, and then it'll teleport. So something like this, and now it's a little bit random, like you'd see something in a video game. So I will, still pretty easy because his x coordinate doesn't change. So once I get into the area, you're still going to pretty much get him eventually. So, but that was a couple of things in the discussion that I had to think about as far as what we could do to improve it. And if you have any more suggestions, you can send them to me. My email address is craig.sap@scpss.com. And you can just send me an email if you have any thoughts. Next webinar, I'll be doing blackjack. And although blackjack is a fairly simple game, the details of that game are much more here than the Flappy Bird. So look forward to seeing you then, and that's enough for now.